Anyone who falls into a black hole never actually dies, at least not from the outside observer's point of view. They're frozen forever at the event horizon, like a photograph. But to the person falling in, it's the complete opposite. They're torn apart in less than a second, and in their eyes, the entire universe accelerates into a frenzy. Billions of years flash by in an instant. Finally, every star in the sky goes dark at once. That's what makes black holes so terrifying. They don't just kill you. They make you watch the end of the universe firsthand. But the weirdest part is yet to come. Scientists recently discovered black holes may not actually destroy everything. Every piece of information about you, every memory, every thought gets encoded on the black hole's surface, like words carved into a tombstone, impossible to erase. What does that mean? It means the you swallowed by a black hole might not truly disappear. You become part of the black hole, existing in a form we can't even begin to comprehend. Now, let's start from the beginning. What exactly is a black hole? How are they born? The answer lies in the death of stars. When a star more than 20 times the mass of the Sun reaches the end of its life, its core runs out of fuel. It can no longer generate enough heat pressure to fight its own gravity. In less than a second, the entire core collapses under gravity. The outer layers plummet inward at incredible speed. The energy released in this collapse is so immense, it can outshine every star in the Milky Way combined, for a few seconds. That's a supernova, the universe's most spectacular fireworks show. But the real horror comes after the explosion. When the core is compressed to its limit, all atomic structure collapses. Protons and electrons are crushed into neutrons. Eventually, even neutrons can't hold. Under general relativity, no known force can stop gravity from compressing further. Matter collapses into a point of infinite density and zero volume. A black hole is born. You might wonder, how many kinds of black holes are there? Even stranger, there are 3 completely different types. First, stellar mass black holes. The ones formed from dying stars, typically 5 to 100 times the Sun's mass. Second, supermassive black holes, lurking at galaxy centers, with masses millions or even billions of times the Sun's. How do these form? It's still one of astronomy's biggest mysteries. Scientists have a bold hypothesis. In the universe's first few 100 million years, there may have been primordial gas clouds tens of thousands of times the Sun's mass. They skipped the star phase entirely and collapsed directly under their own gravity, forming black hole seeds. Third, intermediate mass black holes. Between 100 and 100,000 solar masses. They might be the bridge between stellar and supermassive black holes. In 2020, the gravitational wave event GW190521 confirmed for the first time a black hole of about 142 solar masses. A black hole's appetite is never satisfied. Once born, it grows in 2 insane ways. First, devouring. When gas, dust, or even stars get too close, they're ripped apart and form a super-fast, spinning accretion disk. Inside this disk, matter moves near the speed of light. Friction heats it to hundreds of millions of degrees. The X-rays and gamma rays it blasts out are detectable from billions of light-years away. In 2011, astronomers watched a star get shredded by a black hole in real time. The show lasted for months. Second, merging. Black hole mergers are even more violent. On September 14, 2015, humanity detected gravitational waves for the first time. 2 black holes, 29 and 36 times the Sun's mass, 1.3 billion light-years away, completed their final death spiral. Orbiting each other at half the speed of light, they merged into a single 62 solar mass black hole. The missing 3 solar masses were converted into gravitational wave energy in 0.2 seconds. That energy radiated across the cosmos. In that instant, the power released exceeded the total light output of every star in the observable universe. Here's a counterintuitive fact. Black holes aren't destroyers. They're builders. Astronomers found that nearly every large galaxy has a supermassive black hole at its center, and the black hole's mass is precisely proportional to the galaxy's bulge mass, about 1 to 1,000. This means black holes and galaxies evolve together. When a black hole feeds, it shoots out two jets perpendicular to the accretion disk. These jets travel near light speed and can stretch hundreds of thousands of light years. The energy they carry heats gas in the galaxy, preventing new stars from forming. This regulates the galaxy's evolution. Without this feedback, galaxies would burn through all their gas, form stars too fast, and die young. Black holes are the heart and brain of galaxies, controlling their fate. Do black holes die? Yes, but the process takes so long it's almost hopeless to imagine. In 1974, a young physicist named Stephen Hawking proposed a revolutionary idea. Black holes aren't completely black. They slowly leak energy through quantum effects. This is Hawking radiation, but it's agonizingly slow. A solar mass black hole would take 10 to the 67th power years to evaporate completely. The universe is only 13.8 billion years old. The 4.3 million solar mass black hole at the Milky Way's center would take 10 to the power of 99 years to evaporate. By then, every star will be long dead. Every galaxy dissolved. Even protons will have decayed. The universe will be dark and silent forever. Black holes will be the last objects to die. Their evaporation will end with one final faint flash. Then, nothing. Humanity's exploration of black holes has only just begun. On April 10, 2019, the EventHorizonTelescope team released the first photo of the black hole in M87. That glowing orange ring stunned the world. On May 12, 2022, we photographed Sagittarius A star, the black hole in our own galaxy, our cosmic next-door neighbor, and gravitational wave astronomy now lets us hear black holes collide. According to LIGO Virgo Cagra data, by the end of 2023, we had detected over 90 gravitational wave events. Almost weekly, a new black hole merger is found. Future space-based detectors like LISA, the Laser Interferometer Space Antenna, will detect far more distant and massive mergers, helping us decode the early universe. Unsolved mysteries. Black holes still hide countless secrets. What really happens at the Singularity? Do black holes connect to other universes? Does information truly vanish inside? The answers may require a completely new theory of physics, one that unifies general relativity and quantum mechanics. When that day comes, our understanding of the universe will leap forward in a revolution. 3 sentences to remember about black holes. A black hole isn't a hole. It's spacetime's ultimate prison. A black hole isn't a destroyer. It's a galaxy's architect. A black hole isn't eternal, but it will be the universe's final witness. Black holes, the most extreme objects in the cosmos, are telling us with their very existence that reality is far wilder than imagination, and the exploration never ends.